I'm going to show you how to use two traces to make a perfectly aligned ledge grab. Jumping at a wall, we can latch onto the edge of an object. We can either jump again to launch ourselves up, or press our back input to detach from the wall. If the wall is too thin, we can make it so the character doesn't grab the ledge at all. And the alignment of our character will be perfectly aligned with the boundaries of the wall, be it a basic shape, custom mesh from Fab or Blender, or a blueprint with multiple meshes. So, let's just get into it. Starting off, of course, with a third-person template. We're going to open up our third-person character. And I'm going to start off by making timers. We don't want ledge grabs to be running continuously. So up to the top right here, I'm going to create a custom event. And this is going to be our start grab timer. I'm going to make another custom event to stop our timer. From our start grab timer, we're going to set timer by event. We're going to promote the return value to a variable. We'll call it grab timer. Our stop grab timer is just going to clear and invalidate the timer. And to the right of this, I'm going to create the custom event to handle actually doing the traces for our grabs. And I'm going to call it grab trace. And dragging off the event for our timer, I'm going to create event and select our grab trace. I want this to be looping. We can get by with probably 0.05 for our timer. And we want to start this timer when we're jumping or when we're moving, depending on what you want to do with your game. I'm actually just going to put this on our jump. So now anytime we jump, we'll be starting our trace. Now we reach our first design decision. You can either have it so then this trace runs whenever we're in the air, meaning that if you jump up to a ledge, we can latch onto it, or you can have it in the more traditional way that if you are falling from the apex of your height downwards, that's the only time that you'll be able to grab an object. I'm going to opt to do the latter, so I'm going to take my character movement, and we're going to get velocity. Going to split the pin, check to see if Z is less than 0. And connect that to my branch here. Now, depending on how you design your level, the traces that we do are going to have a big impact on how we set our actor's location and rotation. A lot of tutorials I've seen rely on line traces, which are okay if your level design is fairly blocky, thinking like old N64 style titles, where you have big areas of just flat terrain. You could also do a capsule or sphere trace to add a bit of thickness to the trace, but then we have some niche issues if you try to land on something that's like a bar that is round. You don't want your trace to also be round because the impact point is going to be non-uniform. So to circumvent these issues, we're going to be using the box trace by channel. And we're going to get our starting point to be at our actor's location a bit forward. So we're going to get actor location. We're going to get our actor's forward vector. We're going to multiply the forward vector. And this is going to be how far out you want your ledge grab to be able to reach. So I'm going to convert this to a float. And we're just going to say 45 for a start. We'll add the location and the forward vector. And we also want this to start a bit ahead of our character. So I'm going to add 100 to the Z value. And it doesn't need to go for the entirety of the length of our actor's location. So we can have it be the midway point between our location and this 100. So I'm going to duplicate this add. We're going to say 50. That's going to be our end. Now the orientation that we have has to be our actor's rotation. Otherwise, this is just going to be the coordinates in world space. So when we turn our character, it's still going to have our half size equal to whatever we set it to. So get actor rotation, connect that in. And then for our half size, we can have this be, start with 25 for the X value, 5 for the Y value, and 1 for the Z value. I'm going to change this to persistent, and I'm going to compile it. And I'm going to run this in the new editor window. And this is how our box trace goes. Now, what you'll see is that when it's overlapping, this is roughly as far as we're going to get for our grab. So our first trace handles both the distance ahead of us that we want to grab, as well as how high we want to be able to grab. So now if we hit with our first trace, we're going to be doing another box trace. This box trace is going to be from our actor's location forward. This way, when we impact the object that we collided with the first trace, we can get the information from its side. That way we'll be able to get the rotation a lot easier. But what we're going to do is break the out hit. Then we want to copy this actor location and forward vector information. Connect it here. We don't need this to be anywhere near as far out as 45, so we just change it to 5. We are going to break this pin, or sorry, split the pin. Then we are going to make vector. Connect the X to X and Y to Y, and connect that pin to start. And for our Z value, we're going to take the impact point and break the vector and connect it to Z. And our end to the trace is going to be our actor's location. Sorry, the hit actor's location. And we can add just a bit to the actor's forward vector here. And then we connect this to the end. Change the half size to 5, 5, 5, because we just need it to be a cube. So we'll compile this. And you can see the only purpose for the second trace is just to have us impact the wall at its side. This way we can get the actor's rotation. All the other information we can get is from the hit actor node, which I'll show you in a bit. But for right now, we want to actually have this latch onto the wall. So we're going to have another break. We're going to take our character's movement, and we are going to stop movement immediately. And set our movement mode to none. And then I'm going to create a variable that's just a Boolean. Call it grabbed, and this is what we're going to set for our animation. And we can compile it and test it again. Now, we don't want this to actually stop on a wall unless we are impacting the top of a ledge. Now, a lot of people may go through and do a third line trace to see if there's any space above, but if we check our out hit results, you'll see that there's this distance node. It says the value is 0 if there was initial overlap, meaning that the trace starts already in an object. So we can drag this up and get the greater than 0. And so we are going to get an AND bool. So if we are hitting and the trace is greater than 0, meaning that it is not an initial overlap, only then will we go on to the next trace. So now we are no longer latching on. However, if we go over to this, we'll see that is a viable hit, and then we are able to grab. So before we go any further, let's line this up with our animations. So we're going to be opening up our animation graph. We'll go to the third person character. We can open it from the anim class here and open up Manny. And I'm just going to cast to VP third person character. And we will get player character. And then drag down here and we can get grabbed. Promote that to a variable. And we'll just set it at the end here. Then in our anim graph, we want to go to our main states. And since we're doing this off of jumping, we're going to drag off and we are going to add a state. I'm just going to name it grab. So from jumping, we are going to say if we are grabbing. And the animation that we're going to be using is one that I made myself, which is the ledge grab animation. And if you have a looping animation, set it to be looping. And we no longer want to be grabbing if we are falling back into the fall loop. So we will get not cool. And then we also need to go from our fall loop to grabbed. So if we are grabbing, okay, and that is of course a bit weird because we have our animation is rigged. So I'm just going to remove the control rig. All right, so now we latch onto the wall, we change our animation, and now we need to scale this so then it lines up perfectly with our ledges. So with that being done, I'm going to close the animation graph, and we're going to be dragging all this back a bit further. So we're going to break the out hit of our second trace. Now we want this position to scale regardless of what object we're on. If you have a basic shape, or you take the objects that come with the third person template that's already in the level, or if you have your own blueprints or assets that you import from Fab or any other marketplace, they all have different pivot points, different root locations. The only thing that we can consistently go off of is by getting the information from the actor's meshes. So we can get the hit actor, drag out, and we will get actor bounds. We're going to split both the box extent and the origin. The origin point is the center of the mesh. So we're going to add this to the box extent, which is the center out to the edge. We will have to have some manual adjustments because our location of our mesh for our actor, Manny, is going to be roughly half the size of the capsule. So we want to deduct half the capsule height. So if we get our capsule component, capsule half height, and subtract this, that should give us a very accurate location. We need to set the actor's location. And to handle the location, this is going to be our grab height. So I'm going to promote this to a variable because we will want to reuse that again. I'm going to change it to grab height. And we're going to get the make vector node again. And our grab height is going to be equal to Z. Now we want to get our X and Y value. So we're going to get the location of our hit. And then we are going to break this. And we'll have to move this back, but I just want to show you for right now. Just connecting that to the X and Y. So it would help if I actually change the collision on this. So it didn't impact with the camera, so you can see where we're ending up. Our character is sunk in, but is setting the location very close to the height. We just want our hands to be a little bit lower than that. But to get our character to back up, we're going to get our actor's forward vector again. And then we can multiply this. And this is going to be our distance to our grab. So I'm going to just change this to a float for now. And we're going to put in a value of 50. And we're going to split this. And we are going to be subtracting this from the current location. So for our X break, we're going to subtract. We're going to do the same thing for Y. And we are going to subtract the X and Y of our forward vector. That'll be our X and Y here. And we can manually adjust the grab height in accordance to the animation that we're using. I think it just needs to be 5 units lower, and then we'll look better. Okay, so now we can see our character is lining up the hands a bit, but the rotation is a little bit off. Luckily for the rotation, it is a lot easier. You're going to set actor rotation. And we are going to take the normal. And then we're going to multiply it by -1. Then we're going to drag this over and get rotation from X vector. So now if we latch on from the side, character snaps over a bit. Still not perfect, but we will do adjustments for that. I'm just going to take a moment to clean this all up. All right, so the next thing I want to do before we fix the location and rotation, I don't want to keep restarting this over and over again. So we're going to create a custom event. And we are going to call it detach. And for our detach, this is just going to be getting us off of the wall So whenever we detach, we want to set grabbed to false because we'll no longer be grabbing. We want to get our character's movement and set the movement mode to walking. And if you want to put this onto your input, say we want to just press back on our key, which is S, we can move this out a bit. And when we're going backwards, our action value of Y is going to be negative. So we can just check to see if it's less than 0. I'm going to create a new variable and we're just going to call it can move. Because we're not going to want to move when we're on our grab point anyway. So if we can move, then we'll move normally. If we can't, then we're going to get another branch. And if we go backwards, then we will run detach. And so when we get up to this point where we are grabbed, we want to set can move to be false. And by default, we want can move to be true. And then last, we want to go down to our attached, and we want can move to be true. That way now when we jump on, press S, we can move normally. If we hit anything else, it does not work. Okay, so going back to our rotation and location, we can resolve the rotation syncing into the location with a little bit of interpolation. And this is also going to be good because when we snap our character to a specific location, it can look a bit jarring. So we're going to be making use of the vinterp to constant node to get our character's location and rotation from where the initial trace overlaps to where we want them to actually go. So we are going to move this can move mode over here. Then we can set timer by event. Create a new custom event. I'm going to call it transition. And just to save space, I'm going to get the set actor location and rotation node. And we're going to remove the old two that we had. We want this timer to be looping. And we could say a time of 0.01 seconds. We're going to get our actor's location. And get our actor's rotation. We're going to get v interp to constant and r interp to constant. Our target is going to be the rotation from x vector and the make vectors. And our current rotation is going to be our actor's location and rotation at the time of our overlap. And connect these pins to the location and the rotation. For the delta time, we could just do 0.05 for both. And depending on how snappy you want it to be, we'll just start off with 75 and you can fool with these values for your game if you'd like. We want to be moving our movement nodes and grabbed up to the timer event. And then we want to do two things. We want this timer to end when we reach the target for both the rotation and the location. So we can right click and type in equals twice. And we'll get the interp to constant here. And we want that to equal our actor's location. And this value down here is tolerance. So when we say that the v-interrupted constant has reached the actor's location for the return value, it's going to be our target location. So the target return value is going to be equal to our actor location, meaning that it's stopped. Then we can go on to our branch. We're going to do the same thing, so we can duplicate that to our rotation and get the actor's rotation. And I find that the rotation is a bit trickier, so we might want to have a small margin of error for that. And then we will get an and. Cool. So if we did reach the location and rotation, we will end. But if we want to end it prematurely, anytime that we detach, we set our can move value to true. So we could say that whenever can move is true, then we will break this timer and end this. So we'll drag off and get an OR bool and get can move and connect that here. And then we can drag off of our timer, clear and invalidate timer by handle, if either of those are true. So we'll try it jumping at an angle, and you can see that we did rotate and we did get to a position where we are no longer sunk into the mesh. And then when we press back, we end. If I jump on and I immediately press back, you'll see that it immediately drops out. And so the last thing that we can do, once we get to this point of being grabbed, we can stop our grab timer. And we can also clean this up a tiny bit. I'm just going to drag everything down. Since we are jumping and falling down when we hit the ground, this trace timer is still going to be running. We're just not running the traces, so we can get an event on landed. And we can stop trace, stop grab timer. Okay, so next thing we're going to be doing is setting up our jump animation. It's going to create a custom event. And I'm going to call it ledge jump. And we're going to play montage. And make sure it's the one that has on completed, on notify, begin and end. And connect the skeletal mesh component. And before we go on to that, I'm going to go to the jump. And we're going to put a branch. So we are going to call this ledge jump if we are currently grabbed onto a ledge. Otherwise, we're just going to jump as normal and start our trace timer. The animation that we're using is the montage that I built, the jump up. You can see I put an animation notify on the 10th frame called jump. When we get to this point in the animation, we want to launch our character up and detach from the wall. So off of notify name, switch on name. Want the notify begin. And we can get rid of the default and add the jump notification here. And first we want to detach from the wall. That way we can actually move and launch our character. And after we are detached, we can immediately launch our character. We'll say just 1,000 units straight up. Okay, the animation's a bit slow. I'm gonna double up on the play rate. And it looks good enough to me. And one more thing we can do is after our move, we'll get a small delay. And then we're going to call our grab timer again. This way, anytime that we detach from a wall, whether it be dropping down to the next ledge or jumping up to the next ledge, we're going to be able to automatically grab it without the player having to manually press jump again. So we grab it, and we're grabbing it again. So one thing about the way that we did these traces is that because the second trace starts immediately where the first one ends, we're able to latch onto really thin objects such as this plane. And we may not want to be able to do that. Same thing with this ledge here. Doesn't make sense because our feet are hanging in midair. We only want to attach to a ledge that covers the full body and has our feet planted against the wall as such. So if we take a look at our second box trace, we'll see the start and end correlate with the Z value of the object that we hit previously. If we lower the Z value for both of these, we can lower our second trace down. So if we subtract, say, 100 units from the Z value of both of our start and end, we're going to have a substantially lower second trace. So we'll break off the end here and we're going to make a vector and connect that to the end. We'll split the pin, connect our X and Y values. We're actually going to be subtracting since our trace starts above us and starts going further down. And these want to be uniform, so we could just promote them to a variable. And this will be grab offset. And we could just put Z at the end specifically for the Z value. Compile it, and we're going to start off with just 100. And that is because we are still at knees length. So let's put this at, say, 140. Now we're missing it, but we're still hitting around the foot. We still want to lower that a little bit so then the trace matches up with the bottom of the right foot. Try 155. I can live with that. And that's how you can get perfect ledge grabs in your game. In the next video, we'll be expanding on this to include grabbing onto bars and shimmying from side to side. So subscribe so you don't miss that video. And as always, I encourage feedback, so comment if you'd like, and leave a like on the video if you did like the video. So thank you for watching, and I hope you've been inspired.